I've been talking to Colin Hales, an expert on electromagnetic fields in the brain, working in Australia, and an editor for Frontiers in Human Neuroscience. I immediately liked this guy. To my profound delight, he wrote this to me in an email. He said, quote, "I know what it is like to battle for the proper airing of a novel idea. I identify with your plight. I also see someone whose idea has yet to become the sunk-cost millstone that captures so many as they queue up to take a number for the Nobel podium," unquote. Sunk-cost millstone. Yep. That is a lovely metaphor for a theory like IIT, into which so much time and money has been poured, it could hold back the authors from making open-minded revisions. Like it or not, my theory and I are not in that position, and that enables me to hold on to humility in a spirit of learning and discovery. Colin and I have been corresponding these last couple of days about my submission to the journal's special issue. My endeavor for this episode is to explore some of the ideas about electromagnetism that Colin has shared with me. Colin said this, quote, "If you elect to persist with the frontiers context, let's see your TICL EM dance. However you interpret things, I know it'll be worth reading," unquote. I wish I shared his confidence. In any case, this episode will be my attempt to informally engage the TICL EM dance. I admit to having a very naive conception of electromagnetic fields. I'm aware that the local field potential measured in EEG experiments must reflect EM. After all, no particle is moving from the cerebral cortex through the skull and flesh and into the recording electrode adhered to the scalp. Nor are the particles doing anything more than moving about within and between neurons in the extracellular space. The implicit assumption in my neuroscientific education is that we are measuring by means of EEG a side effect of the real action going on among the cells of the brain. We act as though the motion of particles, usually sodium, potassium, and chloride ions, along with various specialized molecules and their receptors, is doing the real work of which we are interested. The resulting model might look like a street map with delivery trucks, conveying their cargoes from place to place along discrete pathways, the outcome of which is to export the final results in the form of thoughts or behaviors. I don't believe in this model. In fact, spelling it out here reveals its absurdity. It reads like John Searle's Chinese room. Yet one gets to something like this if he begins with a single neuron and imagines wiring them together into a circuit. One is tempted to escape from the hard problem of consciousness by noting the great number of neurons included and the great complexity of their interconnections. On the opposite end of the spectrum, one invokes supernatural souls and extra-dimensional mumbo-jumbo. This again hopelessly sidelines the hard problem, offering no better an explanation of consciousness than God works in mysterious ways. If the painstaking work of pioneers in theoretical physics, Einstein and Faraday and Maxwell, had amounted to nothing but mystery and failure, we might be justified in taking a defeatist view toward the project of mind and brain, but they didn't. So suppose we stop making excuses and get down to business. My theory, the TICL, is dependent on causality. Causality implies the transfer of energy from one thing to another in time. In the Newtonian sense, one object bumps into another and causes the second object to move in accordance with the force with which it struck. Force. Force, then, is a means of conveying energy from one thing to another thing. I've just been reviewing the book Fundamentals by the Nobel Prize-winning physicist Frank Wilczek. In a section on electromagnetism, he writes, quote, "To sum up, from forces we are led to fields, and from quantum fields we are led to particles. From particles we are led to quantum fields, and from fields we are led to forces. Thus we come to understand that substance and force are two aspects of a common underlying reality." Unquote. All right. Particles are localized disturbances within a field, not an altogether different thing. I guess I might think of a field as the area over which a force has effect. There are four fundamental forces: the strong force, the weak force, gravity, and electromagnetism. Gravity might be the easiest starting point. In the vicinity of mass, there is a gravitational force that will act on any other mass. This force is quite weak, so it really only matters in the case of large masses, like that of planets and stars, and even then, the force diminishes with distance. So is it a force field or a force gradient? Colin Hales said that the brain is 100% an electromagnetic object from the atomic level up, which is to say it beyond the subatomic level. He isn't specifying the brain in particular. He means that materials of all kinds, living or otherwise, are electromagnetic objects. Mass in the brain expresses a gravitational field, but this is very, very weak compared with electromagnetism. The strong and weak forces are involved with what goes on inside the atom, so they aren't the droids we're looking for. When we talk about ions moving about as a means of electrical dynamics across the neuronal membrane, we must, therefore, be dealing with electromagnetic forces when we talk about causality. Remember, force is the carrier of causality. I guess I can't argue with this premise. Colin pointed out that there is no empty space in the brain. There are two fields, electric and magnetic, and each fills the entire space of the brain. These fields extend beyond the bounds of the tissue, which is why we can measure them with EEG and magnetoencephalography, or MEG. He said that every measurement ever made in support of any theory of consciousness is an interaction between an instrument and the EM field of the brain. This includes everything chemical and everything mechanical. This makes sense to me, I've just not thought it through explicitly. When one object approaches another, what do we really mean by contact between them? It must be that the electrons surrounding the atoms which are approaching repel one another as they get very close. Do the electrons come into direct contact? I don't think they do. They repel one another because they share the same charge. But how exactly is that charge expressed? It must be expressed in the form of a local field, just like bringing the same pole of two magnets into proximity. Physical interactions have to be mediated by EM forces or one of the other three forces. It ain't gravity that makes two billiard balls crack together and roll in opposite directions. In an interesting turn of phrase, Colin said that a neuron is the EM field behaving neuronally. There is literally nothing else there except space and the sub-angstrom interior of atoms, charge, spin, mass, etc. All right, as a specialized cellular machine, the neuron is an organized EM modulator. Is that it? A typical neuron has a dendritic tree with thousands of incoming synaptic connections. These synapses are localized engines for molecular interactions and ionic flows. This results in local changes in voltage across the dendritic membrane. The sum total of these voltage effects arrives at the cell body, or soma. At the axon initial segment, a neighborhood of the soma, a high density of voltage-gated sodium channels responds to the voltage change in the soma, and a cascade of incoming sodium ions triggers an action potential down the length of the axons toward their own synaptic targets. This material description of the neuron is pretty accurate, though I left out hundreds of known molecular details. The movement of ions across the membrane, which is the mechanism of action throughout this account from dendrite to axon, necessitates the involvement of electromagnetics. But the story I told was a molecular one. Biomolecules, such as proteins and lipids, are the gears that make cellular machines work. They each have their job to do. These biochemical jobs either cost energy or they don't. Millions of years of evolution have tinkered with them. They act as efficiently as natural selection has managed. But what are they doing fundamentally? What is chemistry fundamentally? The interactions of atoms with one another entails covalent and ionic bonds, as well as hydrostatic interactions and so on. Ions of opposite charge attract to one another. That must be electromagnetic forces. Hydrostatic interactions are weaker, with the involvement of partial charge, like weak magnets. That is electromagnetic. What about covalent bonds? In the classic description as I remember it, certain types of atoms preferentially share electrons. You might remember these pictures with the electrons shown to orbit around the nucleus. In the bond between two oxygen atoms to make a molecule of oxygen gas, 2 electrons are shared between the atoms, or so the model shows. Are these the same 2 electrons all the time? What about the electron cloud? What about quantum mechanics? It is probably more accurate to say that the atoms have fused into a new structure, preserving their independent nuclei, but now have a non-spherical electron cloud. O2 is quite a different thing than simply 2 atoms of oxygen. It has different properties. What could those new properties be but EM field properties? Damn, I'm starting to get the man's point. I could admit to not understanding the details, though. Colin said, the causality that I refer to in the TICL is entirely a product of EM field action, the Lorentz Force. It does everything. All action potentials, all the through-space coupling, all the things that I identify as network activity and electrochemical, these are EM field activities. I looked up the Lorentz Force since I am woefully undereducated in physics. Lorentz Force is another name for the electromagnetic force. the combination of the electric and magnetic forces on a point charge that is moving in an electromagnetic field. Cue equation, cue urge to kill oneself. According to Frank Wilczek's book, Michael Faraday discovered a law of induction which says that magnetic fields changing in time produce circulating electric fields. Maxwell's law of induction extended this to say that electric fields changing in time produce circulating magnetic fields. Maxwell further concluded that radio waves, X-rays, and visible light are disturbances or waves in the electromagnetic field. Wilczek writes that electromagnetic fields fill space and must be included in the ingredients of the universe. In his book, he shares this from James Clerk Maxwell. Quote, "The vast interplanetary and interstellar regions will no longer be regarded as waste places in the universe, which the Creator has not seen fit to fill with the symbols of the manifold order of His kingdom. We shall find them to be already full of this wonderful medium, so full that no human power can remove it from the smallest portion of space or produce the slightest flaw in its infinite continuities." Unquote. Is this true? Is the whole of space filled with a universal EM field? That would certainly explain how electromagnetic waves like photons and radio waves can travel through empty space over vast distances, as they evidently do. If that is the case, then interactions between charged particles, as occurring in chemistry and standard physics, would not be inducing a new electric or magnetic field, they would be inducing a local perturbation in the one universal EM field, wouldn't they? I asked Colin if this is correct, and he told me that thinking of space as an EM field ground is apt. Built into Maxwell's equations are two major constants: the magnetic permeability of free space and the electric permittivity of free space. This means that space itself is polarizable, both magnetically and electrically. There is a deep, intimate connection of space and the charges and current that originates EM field behavior. That relationship is built into the two constants. Colin said, the endogenous EM field of the brain is not a side effect of something else. The endogenous EM field of the brain is the brain. To be a brain, he said, is to be a collection of EM fields impressed on space by atoms. All right, I'm coming around to that understanding now, but let's not get too precious about it. To be a bowling trophy must also be a collection of EM fields impressed on space by atoms. He went on to say the origins of consciousness must be electromagnetic. Since there is nothing more than the strong force, the weak force, gravity, and EM, the latter captures the entire standard model of fundamental physics. He said that neuroscientists have been abstracting away from EM for so long that they don't even realize it. Yep, I didn't realize it. I feel more enlightened already. What does this mean for the TICL? Well, I don't know for sure, but I'll hazard some thoughts. According to the TICL, there are two necessary components of a structure that must coexist for consciousness. One, a system of integrated elements, each of which has some amount of causal power on all of the others over some time frame. And two, some number of subsystems of integrated elements which are a subset of the system and which collectively have a higher level of causal power upon one another than they do with the rest of the system. For the TICL, the system provides a point of view upon the subsystems. More accurately, the temporally integrated causality upon the system experiences the differentiated temporally integrated causality of the subsystems. Thus, the subsystems produce content from the point of view of the system. This gives us a unified conscious being which experiences meaningful content. How can I convert this description into an EM field account of consciousness? It hinges on the identity of an element and the physical manifestation of causality. An element in the brain is a single neuron or a small number of network neurons which function as an irreducible unit. Okay, so what is a neuron? A neuron is a specialized eukaryotic cell. It has a structure composed of biomolecular subunits arranged in space. It's an elongated wetware device, a biochemical factory. Okay, what does the biochemical factory make? What does it reduce to? I have reduced it to an implementer of causality. Any device could be described that way, couldn't it? How does a device implement causality? By force. What force? Well, apparently electromagnetic force. It's not gravity, or the weak force, or the strong force. It's got to be EM. So temporally integrated EM? This might be a more accurate physical description. I don't see that this changes the TICL mechanistically, but it might. Furthermore, it could be that specifying EM has theoretical and philosophical implications. The hard problem of consciousness is to explain subjectivity. We haven't proceeded toward a better explanation of why the neural correlates of consciousness make subjectivity possible. Temporally integrated causality has subjective character, is no less radical a claim than the claim that temporally integrated EM has subjective character. But at least EM is a real physical force, while terms like information and causality are less defined. A further implication that I would rather avoid is a form of panpsychism that I'm not prepared to support. I would not claim that it is like something to be causality or information, and I am not prepared to suggest that it is like something to be an EM field. Rather, the TICL makes the proposition that it is possible in our universe to arrange something physical, perhaps to arrange EM fields, in a manner that produces consciousness. The arrangement is like a landscape. The features of the landscape exist from the point of view of the whole. Maybe the landscape is composed of interacting electromagnetic fields. The interaction of these EM fields is such that it maintains continuity in time. One field warps another field, which in turn warps the first, and all within a wider field which appreciates the warping in the form of qualia. That would be a big but inexpensive theoretical step forward because it would begin to situate the conversation in terms of fundamental physics. But it is the arrangement that makes it like something to be. It is the arrangement that determines exactly what that something is. And it is the uniqueness of the arrangement's position in space and time which makes it subjective. The brain is not conscious. A substantial part of the thalamocortical system in the brain is conscious, and it's only conscious during certain states of activation. EM can be measured by means of EEG or intracranial field recordings during conscious as well as non-conscious states. But the arrangement of thalamocortical EM in space and time is another matter. Whatever it turns out to be, it is the physical arrangement which will specify the neural correlates of consciousness.